This is Physics 1 course. In this video, I will solve an example on constant acceleration motion. A ball is thrown at the speed of 20 meters per second in a direction that makes an angle of 30 degrees with the ground. Assume that there is no horizontal acceleration. Find the maximum height of the ball. Find the distance that the ball passes before hitting the ground. So first thing is to gather the information from the question. So the speed is 20 meters. So let's first see what the speed is. The speed is the magnitude of the velocity vector. So velocity vector has magnitude of 20 meters per second in a direction that makes an angle of 30 degrees. So if this is the ground, then the ball makes, this is the speed, it makes angle of 30 degrees. So now we need to make our coordinate system. So easiest one is to have this y and this x. Now let's read the rest of the question. Assume that there is no horizontal acceleration. Horizontal means in the x direction. So that means ax equals 0. Find the maximum height of the ball. So we want y max. And find the distance that the ball passes before hitting the ground. And we want x max. So remember we had two sets of equations. One was Vx equals Vx naught plus ax t, and Vy equals Vy naught plus ay t, and x equals x naught plus Vx naught t plus half ax t square, and y equals y naught plus Vy naught t plus half ay t square. Now remember I told you in the previous video that whenever I am working with something that is close to the surface of the earth, then there is always gravity, which has a magnitude of 9.8 and the direction is downward. So therefore I also should know that ay equals minus 9.8 meters per second square. Okay, now let's find the maximum height of the ball. So when the ball reaches the maximum height, Vy is 0. That means Vy at some time, let's call it t1, is equal 0. That is the time that the ball reaches the maximum, because the ball moves all the way up here and then it doesn't go any more higher. It starts to go down. So this is when Vy is 0. So now according to this equation, it equals Vy naught ay, which is minus 9.8, and t is t1 at time t1. This equation holds. So now what is Vy naught? Vy naught is the magnitude of V, which is 20 meters per second, sine theta. Sine theta, which is 30 degrees here. 30 degrees. I found Vy naught using previous videos. So remember we had this, if this is vector v, the magnitude of it is v, which is given to us, then this was vy. And if this is theta, we know sine theta equals the magnitude of the front edge, which is vy, divided by the magnitude of this edge, which is the magnitude of v. So therefore vy naught equals v naught sine theta. So that's what I did here. So sine theta is half. This is equal to half, and this is 20 meters. So this Vy naught is equal 10 meters per second. Put that here. 0 equals 10 meter per second minus 9.8 t1. This is the time that it arrives at the maximum height. So therefore t1 equals 10 over 9.8 seconds. I forgot to write meters per second square here. So this is t1. So if now I put this t1 into this equation, I can find the maximum height. So maximum height is y at time t1 equals y naught equals y naught. So the particle started from the ground. That means y naught is 0. So it's 0 here plus vy naught, which we just found here, 10 meters per second, 10 meters per second times t, which is t1 now. So times 10 over 9.8 seconds plus half ay, we found it here, it was minus 9.8 meters per second square t1 square. So it's 10 divided by 9.8 second square. Now if I use my calculator, I have 100 divided by 9.8 meters, because this second and this second cancel out. So it's 100 divided by 9.8 is 10.2 minus, because I have a minus here, half of that again. So it's half of 100 divided by 9.8, because 9.8 is square and 9.8, one of them cancel, another comes here, so this is half of that, so it's 5.1, and it's meters, so therefore this is also meters. Now let's find maximum x. So make a little bit room here. So we want maximum x. Let's say the particle reaches maximum x at time t2. So I have t2 equals, then I use this equation. X naught is 0, because the way I have chosen my coordinate frame, the 0 of x is where the particle is thrown. So therefore x naught is 0. So plus vx naught. So vx naught is just like here. Instead of sine, I have cosine, because instead of this length, now I should use this length, which is Vx. So Vx naught therefore is magnitude of V, which is 20 meters. So it's 20 meters per second, cosine of the 30 degrees. Vx naught times T2. So this is T2. And half of the AX, which is just 0. So therefore that is also 0. So all we need is T2. Then we get xt2. So now let's go find T2. Now what happens at T2? At T2 this ball goes all the way down and hits the ground. So at T2 y is again 0. So therefore I already know that y of T2 is 0. So now let's go back to this equation again. We know y naught is 0. So this is equal to 0. Vy naught was here 10 meters per second. So plus 10 meters per second times T2 plus half Ay. So Ay is negative. So let's write negative half times 9.8 meters per second square T2 square. Therefore, I can have a 0 equal T2 times 10 meters per second, 10 meters per second, minus half and 9.8 meters per second square T2. So I just factored one of the T2. So now the answer to this is either T2 is equal 0, which is not possible, or this inside the parentheses is 0. So therefore we need to solve for that equation. So therefore 9.8 meters per second square T2 divided by 2 equals 10 meters per second. So if now I cancel m and m, one of the seconds here and another second there, therefore I get T2 equals 2 times 10, so it's 20, divided by 9.8, and second goes up, so seconds. So here is the T2. Now I need to put T2 in this equation to find x at time T2, which is the maximum x. So therefore maximum x, which is x at time T2, equals 20 meters per second cosine 30 degrees T2, 20 divided by 9.8 seconds equals 35.3, and we round the rest. And so now here seconds and seconds cancel out. I have a meter. So this is the answer to the other question. Thanks for watching. Please subscribe to support my channel. If you have any question or comment, please send me an email at open.physics.project@gmail.com. Thank you.